Today, we separate two concepts that look similar but behave very differently. Variables introduce external input. Data sources introduce external reality. They are not interchangeable. One is an entry point into the graph. The other is a read operation against the provider. If we confuse them, we confuse identity flow inside the graph. And once identity is confused, dependencies become harder to reason about. Terraform builds the dependency graph. Every node has identity. Every edge represents the dependency relationship. Variables sit at the boundary of the graph. They are inputs. Data sources sit inside the graph. They are provider-backed lookups. The decision is not stylistic, it is structural. We are deciding where identity originates. Here, subnet ID enters from outside the configuration. Terraform validates the variable's type and structure during planning. It confirms that the value matches the declared type, but it does not validate whether the remote subnet actually exists. Existence lives in provider state. The instance depends on the variable, but the variable depends on nothing. Identity originates outside the graph. Terraform assumes the caller is responsible for existence. From that snippet, Terraform infers one dependency edge. AWS instance.example depends on var.subnetID. There is no edge to a subnet resource. No internal discovery occurs. If the value changes, Terraform treats it as a change in the declared input. It can validate type. It cannot validate remote object existence at graph construction time. Input changes, dependent resource may change. The graph contains declared intent, not proof of reality. This appears similar, but the structure is different. Now Terraform inserts a provider-backed read node into the graph. Data.aws_subnet.selected is not input. It is a discovery step. And in practice, discovery often happens through attributes like tags or other filters, not only by hard-coded IDs. Identity is discovered, not declared. Terraform now builds two edges. AWS instance.example depends on data.aws_subnet.selected, and the data source depends on the provider configuration. During planning, Terraform performs a read. If the subnet does not exist, the plan fails early. Cause and effect are visible. External reality is validated. The graph now contains provider-backed evidence. Ask a simple question. Do you want to control the value or observe the value? Variables are for when you want to control the value. Data sources are for when you want to observe the value. If another configuration intentionally passes the ID here, a variable expresses that contract. If the subnet exists independently and we must discover it, a data source expresses that the dependency. Variables express agreements. Data sources express observations. Variables shift responsibility outward. They allow flexibility, but they weaken internal validation of existence. If an ID is mistyped, Terraform confirms the type, but not the remote object. If environments pass inconsistent values, diagnosing drift becomes harder. The graph trusts the caller. That is power and responsibility. Data sources strengthen validation of external reality, but they introduce coupling to provider state. If the external object changes unexpectedly, the data source reflects that change. Plans may shift without configuration edits. This is not instability, it is truth surfacing. The graph mirrors the provider's current state. That increases safety in some cases and surprise in others. A variable is a root input node. A data source is an internal discovery node. One injects identity, one retrieves identity. The key difference is not syntax, it is direction of responsibility. Variables move responsibility outward. Data sources pull reality inward. When identity flow is explicit, plans become predictable. We should avoid replacing a variable with a data source just to avoid passing input. That hides contracts. We should also avoid replacing a data source with variable just to simplify wiring. That hides validation. Clarity matters more than convenience. Terraform is a graph engine. When identity flow is explicit, dependency reasoning remains clean. Later, we will examine how data sources interact with computed attributes and unknown values. That deepens this distinction further. For now, hold this. Input and discovery are not the same.